Hi everyone, this is the gas walkthrough for July 20th. I'm Philip Newman. I'm actually re-recording this. I realized as I was recording the July 26th puzzle and about to edit it that the grid got shifted over, and I have no idea how that happened. Something got messed up in OBS. But anyway, I am resolving this one and I will re-upload it. But this is No 3 in a Row by Bill Murphy. We have normal Sudoku rules, 1 to 9 each row, column, and 3 by 3 box. Additionally, we have a rule that spans the entire grid, which says that any 3 cells in a row or column that are next to each other like this cannot have the same parity. So we're going to use that up here, so I'll just show it as an example. These are both even. This cannot be even because that would give us 3 evens in a row, so we can deduce that it is going to be odd. And those are the rules. So I'm going to color this one just to make it easier to see what's going on. Coloring is very helpful in this type of puzzle. You don't have to do it, but since we have the option, why not? So we're going to look for places where we have 2 even or odd digits either next to each other or separated like these are. And we know the third cell must be the other parity. So these are all going to have to be odd to prevent having 3 evens in a row. The odds, we can actually put 2 evens here because neither side of this can be odd. This can't be odd, these can't be odd. This can't be odd. Not seeing anymore. Probably one I'm missing somewhere. But this even digit is going to give us a couple of odds here, because we have all of our evens. In fact, that's a 4. That's a 4. And that's a 4. And that's a 6. Good. Get those out of the way. This now must be odd because we have all the evens in the column. These are both odd. We have all the evens in the row. Something just a little, well, these are odd. Something just a little less obvious. Here we have 2, 4, and 6 in the column, and we have 8 in the box. So this can't be even. It is odd. So this is our even digit. This is also even because of these 2 odds. I don't think we can do the same thing here. We know one of these is 6, but we don't know which yet. We can do it here. That has to be odd because there's 8, 2, 4 with 6 in the box. This now must be even to prevent 3 odds here. So this is odd. This is 8. This is 6. This is 8. This is odd because we have all the evens. This is even because of this. And we know that's 4. This is odd. So we don't have a problem making either of these odd. One of them is 6. I don't think we can resolve that quite yet. This is even. You can see we ended up with this diagonal pattern in all of these boxes. That's kind of required if we just take a look at this box. Let's remove our coloring for a minute. We know these can't all be odd, and we know these can't all be odd. So how do we do that if we only have one even digit? Well, the even digit has to go in the intersection. Otherwise, some direction is going to be 3 odds. So we could have figured that out without actually filling in digits or anything, but that's the way we did it. This is 6. These are 2 and 8, and we can do those. This is not 6, 4, or 8, so it's 2. But one of these is 6, one of these is 6. Two odds here. So this is our even digit, and it is 6. I'm going to give us odd here. This can't be 6, so this is. Now these are both odd, which means these are both even. This is odd from these two. This can't be 4, and we have the other evens here. So this is odd, this is even, and 4. The odds here, place even in those cells. So these are 6, 8. This is odd. This is odd because it can't be 6. And we have the other digits here. We can't do the same with 8 up here. Okay, this is even because of these two odds. This is odd because of these evens. Means this is 2, 8, and we can resolve that. And now this is odd because it can't be 8. We have the others up here. This is even in the column, which means this must be 2. And that's odd, which makes that even and makes that odd. And now this is even and this is odd. So we fully colored the grid. We've almost finished our even digits. So let's do that now. And now we're going to look at the odd digits. Often in parity puzzles, the odd digits are harder because there's 5 of them instead of just 4. But we'll see if that's the case here. This cell sees 3, 5, 1, and 7. It must be 9. These are 1 and 7. Let's continue with that. Seven in this box must go here. I'm trying to do this without too much pencil marking, which may be a mistake. This cell sees 3, 5, 7, 9. It must be 1. We have 3, 7 up here, 1 and 5, so that's resolved from this 1. The 5 means this is 5. This is 1, this is 3, 7. Now we're going. 3, 9 pair there. 1, 9 here, so this must be the 3. And 1, 9, 3, 5. This can't be 7, 9, or 1, 5. It's 3. This is 9. This is 3. 5 and 9 and 5. So a couple of naked singles to spot. Maybe there were other options. But once you get going on these, they usually resolve pretty quickly. They're pretty constrained, since you're only placing 5 digits. I like this kind of broken up sort of puzzle where it's almost 2 separate puzzles once you color. And the coloring itself is a puzzle, so it's 3 puzzles in one in some ways. But anyway, that's the solution. I really enjoy these puzzles. I hope you did as well. Let us know in the comments how you did, and I will see you next time.